Welcome to your Algebra 2 Lesson 4.4. Today we're going to be doing something similar to last time. We're going to be solving ax squared plus bx plus c equals 0 by factoring. The difference is today we're not just going to have 1 as the coefficient of x squared. It can be anything. And so the general way to say that is ax squared. So our objective today is to use factoring in the zero product property again, but in this new situation. Now, today we're going to be using something called the AC method. To solve equations in the form ax squared plus bx plus c equals 0, we must first factor ax squared plus bx plus c. Although this factorization can be accomplished in a similar fashion to what we learned last class, this is most easily accomplished by using the AC method. And notice I have absolute value bars around the AC because really we're looking at the absolute value of AC. All right, so for each trinomial, ax squared bx plus c, identify a, b, and c. Then, step 2 is to list all factors of the absolute value of ac, starting with 1, absolute value of ac, and continuing until you start getting repeats. Then you want to consider combinations until you get the correct value of b. Okay, all those little factor combinations, you want to consider them. And the way that you're going to combine them is you're going to add the factors if c is greater than 0 and subtract factors if c is less than 0, and you want it to equal b. All right, so let's actually see this in an example. So we're going to factor 5x squared minus 17x plus 6. So a is 5, b is negative 17, and c is 6. So the absolute value of a times c, 5 times 6 is 30. So we're going to start with our factor pairs, starting with 1 and 30. Then we go to 2 and 15, 3 and 10. Let's see, 4 doesn't work, so 5 and 6. And let's see, 6 would work with 5, but that's a repeat, so we're not going to list it, and we know we're done. C equals 6, so it's greater than 0, and so we're going to add our factor pairs together until we get negative 17. So 1 and 30, we get 31. 2 and 15, we get 17. Well, that's just the opposite of what we want. So b is negative 17, so we'll use negative 2 and negative 15. Will that work for us? Yes, because negative 2 times negative 15 is still positive 30, so that will work for us. So what we do is we're going to re-express negative 17x as negative 2x minus 15x. Notice that that equals negative 17x. It's the same exact value. So we're just re-expressing the negative 17x in a way that will let us be able to factor. So now what we're going to do is we're going to do factoring by grouping. So we've got 5x squared minus 2x minus 15x plus 6. And we're going to look at the first two terms together as a group and the second pair of terms as a group. Out of the first pair of terms, we look at what we can factor out of 5x squared and 2x. We can factor out an x. So we have x times the quantity, 5x minus 2. Then we look at our second pair. Because there's a minus right here, we have to factor out negative something. So looking at 15x and 6, 3 is the only thing they have in common. So we're going to factor out a minus or negative 3. Okay. Negative 15x divided by negative 3 is 5x. Positive 6 divided by negative 3 is negative 2. So at this point we've gone from 1, 2, 3, 4 separate terms to 1, 2 terms. The first term is x times 5x minus 2. The second term is 3 times 5x minus 2. So looking at these two terms, they now have something in common. They have 5x minus 2 in common. So we're going to factor that out. The greatest common factor is 5x minus 2, and then in a pair of parentheses we're going to collect up everything that was multiplied by 5x minus 2. So x minus 3. And there we have our factorization. So our answer is 5x minus 2 times x minus 3. Okay, we're going to do another problem. We're going to do 3x squared plus 20x minus 7. So we need to identify a, b, and c. So a is 3, b is 20, c is negative 7. So the absolute value of a times c is the absolute value of 3 times negative 7. Absolute value of negative 21 is 21. So we want to list our factors of 21. So starting with 1 and 21, 2 won't work, 3 and 7 works, 4 doesn't work, 5 doesn't work, 6 doesn't work, 7 works, and we get 7, 3, but that's a repeat of 3 and 7, so we cross it out and we know we're done. So, since C is less than 0, we want to look at the difference in the two factors. So we've got 1 minus 21, well that gives me negative 20, but we want plus 20, so let's do negative 1 and positive 21. So we're going to rewrite 20x as negative 1x plus 21x. Okay, so if you get the opposite of what you want, just switch the signs. Make the 1 negative and the 21 positive. So we rewrote 20x as negative 1x plus 21x. So now we're going to do our factoring by grouping. So we're going to factor, look at what we can factor out of 3x squared minus 1x. So we'll be able to factor x out of that one. And then 21x minus 7, we'll be able to factor out a 7. So we have 7 times 21x divided by 7 is 3x. Negative 7 divided by 7 is negative 1. So now we've gone from our 1, 2, 3, 4 terms down to our 2 terms. X times 3x minus 1 is our first term. And then we have plus 7 times 3x minus 1 is our second term. So what do they have in common? They have 3x minus 1 in common, so we bring that out front, and then everything else goes in another set of parentheses. So x plus 7, and that is our factored form. So our answer is 3x minus 1 times x plus 7. All right, let's revisit the special patterns that we learned in last class. So let's look at some that are a little more involved. So I've got 9x squared minus 64. So there's only 2 terms there, and it's a difference, so we need to see if this is a difference of 2 squares. So because of the 9x squared, we need to write this first term as one base squared, one thing squared. Well, 9 is 3 squared, so we can write 9x squared is 3 times x squared. That works, doesn't it? 3 squared is 9, x squared is x squared. And then 64 can be written as 8 squared. So we've got our 2 squares there, and we've got the difference. So it's going to be 3x plus 8 times 3x minus 8. All right, here we've got 4y squared plus 20y plus 25. Well, the 25 is 5 squared. We can see that. 4y squared can be written as 2y, the whole thing squared, because 2 squared gives me 4, and then y squared gives me y squared. And then we need to check that the middle term is twice the first base, so 2y times the second base, so 5. So 2 times 2 is 4, times 5 is 20y. Yep, that's what it was. So this is a perfect square trinomial, and so it can be factored as 2y, your first base here, plus 5, the second base, quantity squared. Works if you have a minus 2, or minus as well, not a minus 2 as in negative 2. Sorry, a minus also. We have 36w squared, so that's 6w, the whole thing squared. And then we have a 1, which is 1 squared. And if you check, this minus 12w is equal to negative 2 times your first base, 6w, times your second base, times 1, right? Negative 2 times 6 is 12, times 1 is still 12, and then w. So this factors out to be 6w minus 1 quantity squared. All right, greatest common factors. Don't forget about greatest common factors. We always want to look to see if we have a greatest common factor before we factor the rest of the polynomial. It makes our life just so much easier. So we've got 5x squared minus 45. Now you're going to get really frustrated if you just go right into doing difference of 2 squares here, because 45 is not a perfect square, and neither is 5. But we want to factor out the 5. That's a common factor to both terms at the very beginning, and then the problem's easy to do. So we'll factor out the 5. 5x squared divided by 5 is x squared, minus 45 divided by 5 is 9. Well, 9 is 3 squared, so we've got a difference of 2 squares there, so we can factor some more. We've got 5 times x plus 3 times x minus 3. Okay, we've got 6q squared minus 14q plus 8, so we can factor a 2 out of everything. And so that'll give us 2 times 3q squared minus 7q plus 4. And then using the AC method like we did earlier, we get that 3q squared minus 7q plus 4 is equal to 3q minus 4 times q minus 1. All Right, negative 5z squared plus 20z. Let's see if we can bring out a negative 5 and a z. So it's kind of hard to see there, but we do have a negative. Negative 5z times, well, let's see, negative 5z squared divided by negative 5z is z. 20z divided by negative 5z is going to leave us with negative 4. 12p squared minus 21p plus 3. Let's bring out a 3, and we've got 4p squared minus 7p plus 1. And you can try the AC method all day long, and this trinomial is prime, so the factored form is 3 times the quantity 4p squared minus 7p plus 1. Okay, so now we're going to solve equations. That was our objective all along. Remember, you have to get everything on one side of the equation, a 0 on the other side. We're going to factor, and then we're going to use the zero product property to solve. All right, so let's look at 3x squared plus 10x minus 8 equals 0. So we want to factor, and again, using the AC method that we showed earlier, you can factor this to be 3x minus 2 times x plus 4 equals 0. So we set each factor equal to 0. So we get 3x minus 2 equals 0, x plus 4 equals 0, and so we just solve. So we get 3x equals 2. So dividing both sides by 3, we get x equals 2/3. For the second solution, we subtract 4 from both sides, and we get x equals negative 4. All right. On this one, we've got 5p squared minus 16p plus 15 equals 4p minus 5. Before we start factoring, what do we need to do? That's right, we need to move the 4p minus 5. We need to move those terms to the other side of the equation. So let's subtract 4p and add 5. And that's going to give us the equation in standard form. So 5p squared minus 16p minus 4p is minus 20p. And then the 15 plus 5 gives me 20. Equals 0. So looking at this, I can factor out a 5 and then divide both sides by that. And that's going to give me p squared minus 4p plus 4 equals 0. Please note that we could factor out the 5 and divide both sides by 5 because we had an equation here. When you're just factoring, you just have to factor it out and leave it out to the side. Okay, so now we want to factor. This is a perfect square trinomial, and it is p minus 2 quantity squared equals 0. We use the zero product property. We get p minus 2 equals 0, so p equals 2. And it is a double solution, double zero, double root, whichever way you want to call it, because we actually had 2 factors of p minus 2 to set equal to 0. So p equals 2 is a double root. All right, guys, that's it. Thank you so much for taking such good notes. If you need to go back and look at the AC method problems again and make sure you've got that process down, try the problems to try on your own and come to class and we will go over them. Thank you so much. Y'all have a great day. I'll see you soon.